I'd like to introduce Ben Cefalo, our lead product manager of cloud services at MongoDB. He's here to give a talk on modern data backup and recovery from on-premises to public cloud. A fun fact about him, he works from his Colorado office, but every time you need him, he finds a way to be in the exact office that needs him. And with that, over to Ben.
Thank you. If I can get through this whole talk without falling down there, it's going to be a win for everybody. All right, so again, my name is Ben Cefalo. I'm one of the product leaders here at MongoDB in focusing on all things cloud. So we're going to talk about backup today, which is an exhilarating subject to discuss right after lunch. All right. So real quickly, we'll take 10 minutes and everyone read this. Just kidding. All right, so what we're going to talk about here, and when I talk about backup in today's modern age, is I really hate to talk about disaster recovery. I've been meeting with customers all morning, and I've said this probably in every customer meeting, that I don't like to talk about disaster recovery anymore because it's really about data recovery. And I say that because if architected properly, or if you're using Atlas, which I hope all of you are, that we provision and configure MongoDB in a way that is completely high available by default. So the chances of you ever having to restore or recover from a disaster is not really what I'm focused on or what I want everyone to be focused on. It's more about data recovery. And what I mean by data recovery is when you're using and storing data inside of MongoDB, that someone does a code deploy or someone accidentally drops some data. So your application is probably up and running, but because of a distributed system, when bad things happen to the primary, they start to replicate through. So it's not the fact that you might be down here or that you've lost a facility in the old term of what we considered it to be a disaster. It's really about getting your data back up and running as fast as possible. So that's why I like to talk about data recovery in the terms of backup in this modern age. So what we're going to talk about first is the future of what we're doing for self-managed and on-prem use cases. As much as I want everyone to be in Atlas, there's still a lot of customers that prefer to self-manage. They prefer to they're still running in their own data centers, and they still need to back up all of their data. So we have Ops Manager. We've had Ops Manager for a really long time. And for the most part, Ops Manager does exactly what it's supposed to do and backs up your data. The hard part is that the architecture today that we have is difficult to manage. It takes a lot of time, and operationally isn't as streamlined as it could be. So if we look at this and we build this out from what we have today, so you have a bunch of databases or clusters that you want to back up, and then we give you a bunch of agents that you get to use with Ops Manager, right? You have your backup agent, you have your automation agent, you have your monitoring agent, and those do all these different functions inside of in front of Ops Manager. Then if you're going to back up, you're going to have a bunch of app servers that manage your backup for you. You probably put them in front of a load balancer. Then you have to have your backup daemons, which historically has housed the head DBs. And if architected properly, in case one of these goes down, these are probably another replica set that you're managing now. Then you have to store your snapshots somewhere, so you have some sort of snapshot store, whether it's the MongoDB block store, an S3, or a file system. And then to enable point-in-time restore use cases, you probably have some oplog stores, which, yes, you've guessed it, it is another replica set. So this works, and it's great, and it does exactly what you need it to do. But there's a lot of infrastructure, there's a lot of storage, and there's a lot of lines in here that really don't need to be there in this modern age. So what we wanted to do is we wanted to simplify this. And when I came on board about 2.5 years ago, that was the first thing that I was asked to do is how are we going to simplify this? How are we going to reduce cost, reduce the storage complexities, and reduce the architecture complexities that Ops Manager has today? And not to mention, we run this ourselves. So Atlas and Cloud Manager share a lot of the similar code bases and architecture that Ops Manager does if you're running it yourself. So we have to operate all of this at a much larger scale than everyone here for all of our customers inside of Atlas and Cloud Manager. So there was obviously some reasons why we wanted to do this for ourselves as well. So again, reducing the footprint, reducing the architectural complexities, reduce the cost so you don't have to have all this duplicate storage, move this data around multiple times. And of course, what we all care about is how do you have better backup performance from restore as well as that initial backup, right? So we've just released WiredTiger checkpoints, which is out in Ops Manager 4.2, as well as MongoDB Database 4.2. It requires both 4.2 releases for the new architecture to take effect, okay? So what have we done here? We've enhanced WiredTiger's capabilities of checkpointing itself. What this really means is that once WiredTiger does checkpoint itself, we now have the agent move that checkpoint into some sort of long-term storage, most likely a block store of some kind, whether it's ours or S3. We've completely eliminated the need for head DBs now. So if you remember my previous architecture document, there was a lot of, depending on how many databases you were backing up or how many clusters you were backing up, there was a lot of heads that you were still maintaining in that architecture. So now those are completely eliminated. So from an infrastructure cost perspective and a storage cost perspective, those are no longer needed. The other thing with eliminating head DBs is that no more initial syncs. So if you've ever had to do this process yourself, the initial syncs are sometimes very painful, especially dealing with very large data sets. So the need for that is just absolutely, completely gone. So again, we've now reduced the storage requirements. We've reduced the architectural complexities because data is not moving to all of these other machines, as well as the infrastructure is much easier reduced, which helps with your operational burden, right? The last thing we've done with this effort is we've consolidated all of our agents down from 3 to 1. So now there's a single MongoDB agent that has 3 different capabilities. It has automation, monitoring, and backup. This also helps with how we divvy up different backup jobs because every single node in your cluster will have all 3 agents on it by default. So now we can dynamically pick the right target or the right source for that backup. And I'll show you what that ordering looks like here in a second. So as a reminder, this is what the architecture looks like today, or before 4.2. And this is what the architecture can get down to with 4.2, right? We eliminated all the different agents. We just have the one. You probably still want a load balancer in there. The backup server, or the app servers and the backup daemons can really be combined to a single one because all the daemon does now today, or within the 4.2 realm, does a lot of orchestration and helps with restores, but it's no longer housing the head DBs so that you can highly reduce the amount of architecture or infrastructure needed to run those. So let's talk about the order for a second. As I said, every agent now is going to exist on every single node of your cluster. So what this means is that we can be a little smarter with which node we're going to use for backup, and we'll pick another one if that node is not available. So the first thing, on the first time you set this up, the first thing is going to be we're going to look for a hidden secondary. And the reason we're going to look for a hidden secondary first is we don't want to affect performance against your production cluster or the live cluster. So we first look at a hidden secondary. So if you don't have hidden secondaries, you might want one for the cases of backup. Subsequent backups will always try to pick the node that we've already used for backup. If we can't, we then try to find another one. We also then look for another one in the case of that we might have already used in case that first hidden or second hidden secondary wasn't available. If we can't do that, then we try to find a secondary that has the closest time to the actual desired snapshot time that we can achieve. So based on when your schedule is, we try to select one that is up to date and available, and we take it from there. If that still doesn't happen, then we just say, okay, look, we need a backup. We're just going to take one. And if for whatever reason that there is no secondary available, or if there's a high latency within replication, we'll just take a backup from the primary. But we really don't want to take a backup from the primary, as you can see why we have all of these other options available before that. So we've broken this up into phases. And so for the phase 1, which is what we're in right now, As I said earlier, requires Ops Manager 4.2 with the database 4.2 with an FCV version of 4.2 as well. Ops Manager is backwards compatible, so if you can upgrade to 4.2 Ops Manager but still back up older MongoDB versions. We just use the older architecture, so it supports both. And even in the 4.2 with 4.2, you can set the FCV version to 4.0 or less, and we'll use the old architecture as well. So you really do have a lot of different options here as you migrate eventually to the new backup architecture. So as I mentioned, daemons are used just for background tasks now, no more heads. As of today, we are only supporting replica sets only. Sharded clusters is something that is in active development now. It'll be released and backported to 4.2 something in the next month or two. And we're going to be rolling out additional feature parity features as well, and as of some optimizations. And I'll run through those here in a second. So this is what the architecture looks like just with 4.2. Where we're really going with this is we want to reduce the infrastructure even more. So the first thing we want to do is we want to have enhance the agent's ability to write oplog directly to the oplog store, as well as write the checkpoint directly to the snapshot store, so we can eliminate the daemons. The other thing, let's stop there for a second. So we have the oplog store and just the snapshot store now, and eliminating everything else in between. Of course, you still need the Ops Manager servers, but we want to get to a very limited architecture. We also want to have the ability for the agent to write oplog directly to a different type of store than another replica set. So we're going to enhance that to be able to have the oplog just be written to an S3 or an S3 compatible store. So what that means is if you're running self-managing in like AWS, you could use S3. If you're self-managing on-prem, a lot of customers now have on-prem S3 stores, whether it's a Hitachi, NetApp, or whatever else, will be compatible with those as well. Some other things that we're looking at doing later on in the future is, the first thing is being able to leave a snapshot or a checkpoint behind. And what that means is that, like, on a rolling basis, we use a little extra storage on each database node, and then the checkpoint would be local, or at least the last checkpoint would be local, so you could get to a point of near instantaneous restores, number one. Secondly is, right now, every checkpoint that we're taking is actually a full checkpoint, and we want to speed this up and make it faster by only having incremental checkpoints, storing the metadata ourselves, and then stitching it back together when you want to do a restore back to that point in time. So this would help with how much data we're actually moving around the network, and being able to also reduce your storage requirements for that snapshot store. And then we're enhancing our agents and doing more things with different network protocols so we can more parallelize the data copy from the nodes back to the snapshot stores. So again, always trying to improve performance, making it faster, and being able to move data around a lot more efficiently than we can do today. All right. That was all the Ops Manager stuff. So let's talk about Atlas. So as I said earlier, where I don't like to talk about disaster recovery is because when you deploy a cluster inside of Atlas, no matter what provider, no matter what region you choose, unless it's a region that doesn't have more than 1 or 3 availability zones, which most of them do today, we always will put a node in each availability zone so you are highly available by default. And this is really important for data durability and to keep you up and running as much as possible. Some customers, though, do want to have better availability in case of a regional failure. So we support that too. So with a click of a button, you can have an architecture like this inside of Atlas that allows you to have multiple regions across large geographies, whether you want to have like East and West in the United States, or you even want East and West in the United States and have your third one be in London. We can deploy into an architecture like this so we can withstand an entire region failure because you still have quorum over all the other available availability zones. So this is possible. So that protects you from disasters. But now, again, as I said earlier, it's all about data recovery and what we can do from a data recovery perspective to get you back to a point in time where you might not be missing the entire cluster, but maybe you need to get some data back. So for a while now, we've had point-in-time recovery, where, as I mentioned earlier, we're storing the op log in various places, and we can restore back to that window. Right now in Atlas, we have minute granularity on replica sets, 15-minute granularity on sharded clusters. We will restore to the closest snapshot to reduce the amount of time it takes to do the restore, and then roll ahead the op log. We really try to limit this so you don't have to restore a snapshot and then spend a day or two rolling ahead op log if your closest snapshot was like from a day or two ago. By orchestrating it the way we do, it reduces to the least amount of possibility of data loss, getting back to that minute window. But then we have smaller disasters, let's say, where perhaps someone deployed some code, someone accidentally dropped a table, but in general, your application's up and running and it's completely fine, right? But maybe it's just missing like a chunk of data, or there's some users that are affected, but not your entire application, right? So you definitely don't want to take down your whole cluster, right? Because you don't want to affect everybody else. But you need to get back to that point in time, or you want to get back that data that's either been corrupted or lost or accidentally deleted. And it's always a human that accidentally does this, and it happens. So how do we do this? Oops. So in Atlas, as well as this exists in Cloud Manager and Ops Manager today, we have what we call queryable backup. What we do is we mount a snapshot, and we give you a way to query that snapshot in a live format. So you can go and find the data that's missing. You can extract that data that's missing, because all the command line tools work in this tunnel, and lets you put it back into the live production system without affecting the rest of production, okay? And I'm going to show you how this works. And this is just a little simple Python script. And so what it does is it queries the tunnel. The tunnel opens up on your local machine. So I query that data, I stick it into a cursor, and then I write it back into the production system completely live without taking any downtime to restore that data. So let's give this a try here. How small is that? Is that better? Cool. All right, so I have my cluster down here. And if I go into backup, you'll see that I have my queryable restore ready. The way you would start this is when you're looking at your continuous backup snapshots. We're going to talk about a new backup method here in a second. But if you're looking at it here, you can see all the snapshots I have in the system. You can go ahead and click on query, and it goes ahead and mounts this snapshot in the background. Okay, so now I'm going to go to my shell here. And this is the live database system. So I have a bunch of different databases here, so I'm going to, oh, thank you. Is that better? Good? People in the back? Okay, sweet. All right, so this is my live system. So I'm going to use the locations database. I have the zip code collection loaded in there. So if I do db zips, and I was raised in Vermont, so we're going to go query this state. And so there's data there, as you can see. And there's 243 zip codes in the state of Vermont. Perfect. So now we're going to go around and do db zip. If I can type today. There we go. Cool. So now I've deleted 243 documents, and you can see that that data is gone. So I have my tunnel up and running, and since my tunnel mounts, oops, you guys see that? So because when I launch my tunnel, it mounts to my local host on 27.17. So if I pop up another shell now, and I just simply run the shell. I connect to my tunnel, which is now my actual backup that's mounted. So if I do the same thing, so man, I really can't type today. And there are my data that's missing, and I have my 243 documents. Cool. So now how do I get them there? I showed you that sample script. So now I'm just going to, if I do that. So I'm going to run my script, and if I come over to where I have this and I start counting, you can see that it's now querying the tunnel and writing back directly into the production data set without taking down production, but now I'm able to restore that data, get these people up and running quickly without having to do a full restore, provision another cluster, or take down the entire application. So there's my 243 documents are now written back. So simplistic example, yes, but it's a real quick example of the power that we give you with queryable backup across all of our different backup methods. All right. Cool. So with continuous backup, and this is true for both Atlas and in Cloud Manager, we operate backup regions throughout the world. As you can see, there's not a lot of them here. And so we've made some decisions on and some assumptions on data sovereignty and the best places to put your backups depending on where your cluster is running. So as an example, though, if you're someone in Brazil that wants to back up, your default location is to Ireland because there is no backup location in Brazil. So we wanted to change that, and we also wanted to maintain better data sovereignty throughout all the different countries, not just within Europe, but everywhere in the world as having more and more of these new regulations are coming out. And secondly, we wanted to improve performance and improve cost to our Atlas customers for having a better and cheaper backup solution. So about a year and a half ago now, we've launched Cloud Provider Snapshots, which, as the name suggests, we're utilizing the cloud provider's native capabilities of taking snapshots. But unlike doing this or orchestrating this yourself, because we know where the data is in flight, especially with a sharded cluster, we're able to guarantee consistency and data durability across your entire cluster. Because we're utilizing the cloud provider's technologies, we're able now to then keep your backup in the region that your cluster is running. We're also able to support a lot of different incrementality methods that the cloud providers provide us. And then we've also changed the pricing model where instead of billing on data size, we're billing really based on the snapshot size, which is very closely related to your disk size. And then we went from $2.50 a gig, which is what continuous backup is. And the cheapest region we have, because it varies by region, is around 8 cents per gig. And again, it's based on disk size, not data size. And because they're incremental, it's not just a flat rate based on disk. It's actually about all the different snapshots that you have in retention. We add all of that space up, and that's what we bill you on. It's now available in all different cloud providers. We started out with Azure, then we rolled out AWS, and now we have GCP. And so this is what the continuous backup regions look like today. And this is what, with using cloud provider snapshots, and I think I'm missing a couple of regions now, but you get the idea that this is how many regions now we can offer backup locations in. So if you have data sovereignty rules, if you want to keep your backups close to where your cluster is actually running, cloud provider snapshots certainly helps. Okay. So after we rolled this out, we started adding features, because the whole goal of what we're trying to do is as I showed you that architecture from the very beginning, and I said that we run this similar architecture when it comes to like continuous backup inside of Atlas. This is expensive for you, and it's expensive for us. So we don't want to do it anymore. So the goal is to get to feature parity as fast as we possibly can with cloud provider snapshots and have this be the default backup method when you're using Atlas. So we're adding a lot of, one, feature parity items, but two, also new functionality into the cloud provider snapshot options. So the first thing is with bring your own keys. So now we support all 3 cloud providers, regardless of whether you're using AWS or GCP or Azure. We support their versions of either KMS, Key Vault, et cetera, and we will back up, or we'll not only back up your cluster using your key, but the wired Tiger files themselves are encrypted at rest. Now, that doesn't mean if you're not using your own keys that Atlas clusters are unencrypted. They're just encrypted at the disk level using our keys. So and that still remains even if you're using this functionality. So it's, in a sense, double encryption, double protection if you're using bring your own keys. And that key carries forward to your backup. And we let you know which key is associated with that backup. So when you start thinking about like right to be forgotten and all of these other regulations that are popping up, it's very simple to be like, I'm going to rotate this key, I'm going to delete this key, and even if you kept your backups, you could never access those backups ever again because you deleted your key, okay? We've changed the way backup scheduling works in cloud provider snapshots from a scheduler, which is really just like kind of set it and forget it, to more of a backup policy. And the reason why we're doing that is, and what you're going to see here in a second is we're adding more and more granular rules-based backup about when to back up, how frequently to back up. And when we start thinking about the new ways of point-in-time restore, which I'll show you here in a second, it lends itself way better to a policy than it just does a simple schedule. With cloud provider snapshots, we were able to add, believe it or not, one of the most highly requested features for backup was the ability to say, I want to take a backup right now. We can't do this with continuous backups for a lot of different reasons. We can't do it in Ops Manager today. But by having CPS, we're able to now support this use case of taking a snapshot instantaneously. There's an API for this. I have a couple of gaming customers in the United States that love this because they take a backup right before they do a code deploy, and it's just built into their whole CI/CD pipelines. Just note, though, as I mentioned here on the slide, that if there's already a snapshot in progress, we only let one snapshot run concurrently at a time, and that's just simply because in our testing, regardless of what every cloud provider says, if you have multiple snapshots running against a disk on a particular time, it does affect performance, so we don't let you do it. We only run one at a time, and we'll queue them if need be, except for the take your own snapshot or snapshot now. We will give you back an error that says something's already running. We can't take this, so you can properly handle that if you're using the API. About a couple months ago, we did not a really big announcement, but we did launch M2 and M5 backup. So if you're utilizing our development tiers of Atlas, we've just added backup. It doesn't cost anything extra. It's just there and on. It doesn't have all the same features and capabilities, but it is available for you to use. So today, actually, though, I am announcing, and it comes out next week, that we've gone live, or we're going to be going live with point-in-time restores for cloud provider snapshots. We're going to be doing it on AWS first, and then we'll go to the other cloud providers. But we're doing it a little differently than what we've done in the past. Before, with continuous backup, and even in Cloud Manager as well, you only have a point-in-time window of 24 hours. What that means is that we're only saving that op log for a rolling 24-hour basis. So you only can get back to that minute granularity or 15-minute granularity on sharded clusters only within that 24 hours. After that, you can only restore full snapshots. Okay? With cloud provider snapshots with point in time, we can have customizable windows. So if you want 7 days of point in time window, you can have 7 days. If you want 15 days of point in time window, you can have 15 days. We are storing the op log in S3 or some equivalent block store, so we don't have a limitation on a replica set or something else storing that op log. So depending on what your regular requirements are, your RTO or RPO times, we can get and hit any real point in time window that you want to hit. So let me show you what that looks like. All right, so I have my cluster here. And so when we launch this next week, we're not going to retroactively go and turn this on for existing cloud provider snapshot customers. You have to come in here and turn it on yourself because the pricing changes based on whether you have this on or not. You can choose to have this on. You don't have to have it on. So we allow you to have CPS backup without point in time. So for clusters that don't need it, you don't need point in time. But for the clusters that do, you can turn it on. So a lot more flexibility than previous. So when you go ahead and turn this on, it just starts going in the background. You don't have to do anything else but turn that on. Now, when you come into, and for everyone that didn't follow what I was doing, we've moved the backup. If you're using cloud provider snapshots, the backup is now located within the cluster. If you're using continuous backup on other clusters, it's still located on the left. So depending on the version of the backup you're using, depends on the location. But this location as part of the cluster is where it's going to be from now on. So there's a couple of things in here. First of all, this is all where your different snapshots are. You can edit your retention time. So as I said, there's a lot more flexibility in this model of backup. So you can say, if this happened on a schedule, but I really want to keep this for a little longer, you can come in, edit the retention time, and it's retroactive. This particular cluster is encrypted, so if I want to show my key, and this correlates back to my AWS KMS account, so I know which key is being used. So if I want to rotate the key, I know not to delete certain keys that are still in use for the backup if I ever need to have access to that backup. You can do a restore, and we have a new point-in-time restore UI if you've ever done this on the continuous backup. So it's a lot more flexible. We still support oplog stamps and whatnot. And then if we come ahead and come up here to our actual backup policy, a lot more modern of an interface, easier to use. You can pick your time in UTC. You can have all these different frequency units. You can get down as granular as take a snapshot every hour if you want to, but just remember that about the queuing. So if you're running a lot of data, you have a lot of churn on your cluster, maybe a snapshot will take longer than an hour to execute. So if that happens, we will queue a few of them, but we'll reach a certain point where we say we're just going to start skipping them versus queuing them. You can add more frequency units here, and then we have our restore window. And because my maximum daily retention is only 2 days, I only let you have 2 days of window. If I decided to say I'm going to change this to 8 days, I didn't update, but it probably has to dynamically update this way. Okay, like I said, it's not live yet. You gotta love the demo gods, right? But anyways, we tie the restore window to the daily retention time. And the reason why we do this is so we never let you get into a situation where you're gonna restore a snapshot from like 7 days ago and then roll ahead multiple days of oplog. Because then it's gonna literally take a day to probably restore that since we're writing every single thing that you've ever performed against that database in that time period. So we want to get closest to, we want to have a snapshot always available that is super close to the time that you've selected for that point in time restore. So this is dynamic based on that. And then after you change your policy, we do let you retroactively go back and it auto updates all the retention times that you've already, of snapshots you've already taken if you want to or not. And then we also count how many snapshots that we're storing in retention. For cloud provider snapshots, this is less of a billing item. We're telling you, we're counting them for you. But because all the snapshots are incremental, the amount of snapshots you're keeping is really not as a contributing factor unless you're deleting large sums of data in between snapshots, right? Okay, great. Okay, awesome. So yes, of course, it's only the beginning, right? So where we're going with cloud provider snapshots, as I said, we want to eventually, as we iterate on our roadmap, stop offering continuous backup. It's expensive for both you and us, and this is just better. It's faster. So there's going to be even a couple more things we're going to do to even make it even more faster. So the first thing is not so much about performance, but of course we're going to bring point-in-time restores to the other cloud providers. The second thing we're going to do is we're going to work on something that's going to be actually coming out in the next few weeks, potentially. Got to always play the product manager. Direct attach. And what that means is we'll use, again, the best practices of the cloud provider technologies to just attach the snapshot versus having to do a full restore, which is what we do today or what you would do today inside of Ops Manager. So especially if you already have a cluster built and you just want to attach it to the already existing cluster, or if you want to build a new cluster for a dev reason, or you have a lot of other use cases about dev refreshes, or you want to utilize queryable restore, this will be a very quick way to have access to your data, be able to query your backup, and do a restore if you want to. I also want to enhance the cluster builder experience to be able to build a new cluster just seeded from a backup. It's all about user experience with us, and what we want to do is not limit the steps that you have to take to do a backup. So if you could just provision a new cluster and then select a snapshot to seed it from, it all happens in a single path, and when you get that cluster up, it's already restored with your data, and you can just go along your way. This is how queryable is going to work in the beginning. Now, this is not ideal. It's multiple steps. You have to go and build a cluster. I want to make this a lot easier like it is today. I just click the query button. So we are going to optimize special paths for queryable in the future, but today it's still pretty easy and pretty fast with just using regular cloud provider snapshots. And the last thing is something that I'm working on for a while, and we're going to start working on it soon. It's really around selective restore. And what this means is that because we're snapshotting the entire disk of your cluster, we're getting everything. Every collection, every little piece is already there. But we know a lot about your cluster, right? We can store the metadata. We know what collections are in your cluster. The system does. So we could get to a point where you say, I want to do a restore, but I only need this collection. And we just automate that for you in the back end, right? So this is where we're going with this. We want to make it very seamless, very easy to recover your data in the case of a need to do data recovery. And with that, I think we're at the end. And I'm happy to take some questions. I think we have some time left. Thank you.
I think this Atlas basically taking a disk-based snapshots.
Yes.
So how do we do it if Ops Manager is on-prem and clusters are on-prem?
You can't take disk-based snapshots with Ops Manager on-prem. That's where the WiredTiger checkpoints comes in. It's our way of having the same style of backup, but we're doing it with inside of the storage engine.
Yeah, second question. If we have one of the replica member on a cloud provider, so can we register into MongoDB Cloud Manager and manage backups with it?
If you, Cloud Manager can also back up from your on-prem as well. The backup, Cloud Manager is essentially a hosted Ops Manager, but the backups are stored in our backup regions versus yours.
A replica member on cloud.
Yep.
So we can use that to.
No, so I mean, for Atlas, like have a hybrid scenario of like you only have one node inside of Atlas.
Okay.
Is that what you're?
Yeah, we have Ops Manager.
Yeah, okay.
One of the replica sets sits on cloud, AWS.
Yep.
So we have 2 data centers and 1 AWS.
Yeah, that would work. I'm sorry, I guess I just don't understand the question.
So in that case,
yeah.
Can we register that AWS node to Atlas and do the backups?
You would have to migrate it first. It's not, the Ops Manager just can't restore into Cloud Manager
Because a
or.
member should go there.
Yep.
Oh, thanks.
Hi. Once the features are released that you showed in the last slide,
Yep.
is there any reason to use continuous backups rather than using snapshots, cloud provider snapshots?
No, and in fact, I don't have a date yet when I'll start force migrating people to transition to cloud provider snapshots. But eventually, once we get to feature parity, I will start forcing people to go because it's better for you and it's better for us. It's significantly less expensive. The one big contributing factor to why I'm not doing that probably sooner is when you terminate a backup, or when you terminate backup for a cluster, which would be required to turn on the new style of backup, right now the system is set up where it deletes all of your current backups. That's obviously a problem for like regulatory reasons, and obviously you don't want to be without a backup during a transition. So what we're going to do as well is give you a transition path, meaning we're not going to migrate like continuous snapshots to like cloud provider snapshots somehow. We're just going to let you terminate backup but leave all the snapshots behind so you can still restore if need be while you build up a retention cycle of new snapshots.
See, got it. Sure. So one of the common recommendations with respect to cloud provider, taking backups via cloud provider snapshots,
Yep.
is using obviously the user provided key on top of MongoDB white encryption, right? One of the common recommendations is download those backups, store in customer managed AWS accounts or the S3 accounts or equivalent object storage. Today we cannot do that.
Yep.
Right? Is there any thing that's coming up in your?
Yeah, so just to reiterate, if you're using cloud provider snapshots with bring your own keys, we don't let you download your backups. If you're not using your own keys, both with continuous and cloud provider snapshots, we do let you download your backups. Effectively, this is exactly what using your own key is supposed to be doing. We're limiting your possible surface area of an attack or someone by downloading that backup. But because there are use cases for long-term archival or something where you want to put them someplace else, so we haven't figured out exactly what we want to do here, but we're either going to give you a utility to use your KMS key, download the snapshot, and have a way for you to decrypt it, or we're going to do something where you accept the risk, and when we let you download it, we give you an unencrypted version. And the main reason for that is the utilities that we've built inside of Atlas that does KMIP translations to KMS and everything else is something that's not packaged, that we don't let you have that on-prem. So there's no way for you to decrypt that backup. So eventually, yes, we're going to do it. We see the need for that, and we totally understand it, but that's probably a little farther away.
Got it.
We have time for probably one more question, maybe two, if they're quick. Anybody? Going? I know, I'm the new MC. I'm switching this up. Going once? Going twice? I've got one, Ben. Which place do you think is better, Denver or Colorado Springs? There's only one right answer here.
I like all of Colorado.
All right. Okay, better. Okay, thank you, Ben, for your time.